Here is the expression x squared plus 6x plus 3 built out of algebra tiles. How many unit tiles would you have to add to create a perfect square? Okay, so hopefully you said 6 because we need to fill in all of this space with unit tiles. When we do that, we see that we have 1, 2, 3, 4, 5, 6 spots for unit tiles. So that's how many we have to add. Let's try another one. Here is the expression x squared plus 8x plus 6 built out of algebra tiles. How many unit tiles would you have to add to create a perfect square? In this case, we would have to add 10 unit tiles to complete our perfect square. They fit in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if we have negative unit tiles? So this is the expression x squared minus 6x minus 1 built out of algebra tiles. How many unit tiles would you have to add to create a perfect square? Note, you must add enough unit tiles to complete your square and cancel out any negative unit tiles from the original expression. So here we go. To fill in this square, I need 9 unit tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I need one more unit tile to cancel out this negative 1. This brings my total added unit tiles to 10. Let's practice building one together. Given the equation x squared plus 4x minus 5 equals 0, build a diagram of your quadratic expression out of algebra tiles, and then complete the square by adding unit tiles. Building these diagrams to create squares takes a little practice. First, let's start with our x squareds. I'm going to put that in the bottom left of my diagram. Then I'm going to take my 4 x's and split them up evenly. I'm going to take 2 and put them on the right side of my x squared, and I'll take the other 2 and put them on top of my x squared. Last but not least, I have minus 5, so I have 5 negative unit tiles. Those I'm just going to scatter artfully around my diagram. So now we have built our given out of tiles. Next, we need to add unit tiles to make a square. First, I'll fill in my diagram with tiles until I have a perfect square. So here I can fit 1, 2, 3, 4, and there's my perfect square. Next, I need to add tiles until I cancel out all these negative unit tiles. So I need to add 1, 2, 3, 4, 5 additional unit tiles to cancel out these 5 negative unit tiles. This brings us to a total of 9 added unit tiles. Thinking a little bit ahead, when we go to rewrite our equation, we now say x squared plus 4x plus 4 is equal to 9. This is where knowing that we added a total of 9 tiles is important because we need to add 9 to both sides of our equation. Now let's have you try one on your own. Given the expression x squared plus 10x, what would we have to add to make this into a perfect square trinomial? Use the link to access algebra tiles and build your perfect square, then come back and select the correct answer for the number of unit tiles you would need to add to this expression to make a perfect square trinomial. All right, so let's go over how to do this and draw it out. First, I'm going to start with my x squared in the bottom left corner. Then I'm going to take these 10 x's and split them in half, 5 over here on the right and 5 over here above the x squared. Then, looking at what empty space I have, I see that I need to fill that in with 25 units. So to make this a perfect square, I need to add 25. Let's try another one like that. If I have x squared minus 6x, what do I need to add so that I can build a perfect square? Use the link to access the algebra tiles, build your diagram with your given, and then see how many unit tiles you need to make that complete square. Cool. So, like before, we're going to start with our x squared in the bottom left. Then we have 6 negative x tiles. It doesn't actually matter that these are negative x tiles. We're going to build our square the same way. I take half of that 6 and I put 3 negative x's over here. I take the other 3 negative x's and put them up here. And then I can see that the space left needs 9 unit tiles to complete this perfect square. It's also worth noting that even though this is minus 6x, this is still positive 9. This number should always be positive. Let's look at one more scenario, and I'm going to leave this previous setup over here so we can compare it, because what if we had x squared plus 22x? We need to figure out what to add to make this a perfect square. But if I start trying to draw that with algebra tiles, it's going to be humongous, and I don't have time for that. So notice that the negative 6 got split in half. 3 of my negative x's ended up on the right side of my x squared, and 3 of my negative x's ended up on top of the x squared. That same thing will happen with the 22 x's in this expression. Half of them, so 11 x's, will end up next to the right of the x squared, and the other 11 x's will end up on top of the x squared. Now, looking back at our previous model, there were 3 negative x's along the bottom here, and 3 on the left here. And then we did negative 3 times negative 3. That gets us to positive 9. Applying the same logic, if we have 11 down here times 11 up here, we're going to get to 121. I don't think any of us wanted to pull 121 unit tiles out, so now you can see there's a little shortcut.